Good morning, students. Welcome back to our webinar session. Now we are discussing wave optics concept related concepts. So, as we discussed earlier about the waves, the basic information is light is propagating in both the ways, that is based on the two theories that we discussed, Newton's corpuscular theory and Huygens wave theory. So one of the previous questions is light is a wave phenomena, particle phenomena. The third option is both particle and wave phenomena. So we discussed earlier that both the theories are explaining the wave nature, radiation, light. In both the ways, they're correct. And combined is also explained by Max Planck. Okay, so the light exists in both the ways. That is, while we are doing experiments with the light, by considering the light is a wave, then it will give the result in the form of wave. And the same experiment, if you do the light by assuming that is in a particle form, then the result will be in terms of particle only. So this light has a dual nature. So the light is both the particle and wave phenomenon, right? And we'll see the next problem. The light wave can travel. Yes, the light wave can travel in vacuum is given, only vacuum is given, in a material medium, and in a material medium only. So the light has no restrictions because it's a electromagnetic radiation, electromagnetic wave. It only specifically a particular vacuum, it won't, means it can move all the media, okay, all types of media. Only the variation is maybe velocity. Some physical parameters may change, but the light wave can travel in a vacuum and a material medium like glass, water, any chemical, means liquids, anything. Okay, so it can travel. The light can travel. See, the options are 1 and 3 are given. Means there is no restriction, only vacuum or only material medium. There is no restriction. Means it can travel even in pure vacuum and pure material. Right? Now we'll see the next one. The speed of light depends on, yes, this is very, very, very important. So on what factors the light depends? Actually, the medium has these properties: elasticity, inertia. Means elasticity means what? Elongation, when the external force or energy supplied to the medium, means particle or material particle, that medium has a property, elastic property. Means it is actually, it is no way concerned to this question, but it's something tricky type, means tricky type of options are given, but it is speed of light depends on elasticity of medium. Means the medium which is under elongation, like a rubber, that's that kind of medium. Okay, the speed of light depends on elasticity of a medium. No way concerned to that. See, elasticity is the purely medium related. But in previous question, what we discussed, it doesn't depend on any medium. Okay, only medium is not. And inertia of the medium, yes, inertia means what? So that medium has this nature, means either related to the mass or motion. See, it is no way concerned to this. Speed of light is no way concerned to the inertia of the medium, whatever the medium it is. Okay, when it has some permeability, permittivity of these material properties, as long as they are existing, then the light can pass through. See, option is given elasticity of a medium only, no. Inertia of the medium only, no. Elasticity as well as inertia, no. And neither either on elasticity nor on inertia, yes. So this speed of light, neither of these two is depending on, okay, it's depending on neither of these two, either elasticity or inertia. It is no way concerned to this scenario, that is elasticity and inertia. These are no way concerned. These are only the medium properties, material properties. Okay, but the speed of the light, wherever this refractive indices permits, then the material has the permittivity, it can pass through. Okay, right. So D option is correct. Now we'll see the next one. The equation of light is written as, the equation of light is written as y is equal to a sine kx minus omega t. Here y represents what? Observe carefully. The equation of light is y is equal to a sine kx minus omega t. And y indicates what? Yes. Here is the given options. Displacement of ether particles. Displacement of ether particles. And what you understood with this, ether particles means what? Actually, there was the old story that the particles are, sorry, the light is moves only in ether particles, means because of, means atmosphere is full of ether. When the light ray is traveling through that ether, the ether particles are vibrating so that the light ray is traveling. That was a story. But here the y is actually displacement, as we discussed earlier, wave equation. Okay, wave equation, y is actually displacement, right? So now check the question carefully, and what are the options related to this? Yes, question is what? Equation of light, and options are, look at this, displacement. Yes, we know y is equal to displacement only, but not of ether particles, because the light is not restricted to only ether particles. It can move in any medium. That may be water, that may be a medium, that may be gas, any kind of material. Yes or no? So is displacement of, it's not mentioned in the problem that the light is moving in ether. No, that's why this A option is wrong. Okay, now coming to the B option, pressure in the medium. Pressure in the medium. Yes, pressure maybe, yes, when the light is there, temperature is increases, the pressure is also increases. But here, this equation, in this equation, y is not that, because electromagnetic radiation is not only with the heat energy. It may be any kind of energy. So the pressure is also not related, because he's asking only the y. Okay, it's a equation of light is given. So pressure is also not concerned. If a pressure is there, then the area is required. So that is also not there. And coming to C option, density of the medium. See, density of the medium, y is equal to a sine kx means what? Y, if it is a density, what remaining terms represents? Right, density of the medium. How? If density of the medium is more, then what happens? Maybe there is a change in velocity. Maybe there is a change in velocity. If density of medium is low, maybe it moving with a certain different velocity. But the why this equation is related to, it's a light equation. So light velocity in a medium or a vacuum is constant. Okay, moving with a constant velocity. So in the medium density, see which medium is not mentioned in the problem. Okay, so but as per the question point of view, we need to consider that it is moving in a air or vacuum. So there all the terms for the general equation only we need to consider. So displacement ether, so medium is not there, and the pressure in the medium means which medium is there per unit area where the force is applying. So that is also no way concerned. And density of the medium, so how come the density if you don't know the what kind of medium it is? And coming to electric field, yes, there may be a chance of electric field because this wave or light is a chance of electromagnetic radiation. So electromagnetic radiation. So in that both electric and magnetic fields will be present, and one of them and is electric field direction, because both means three components are there: the direction of light, electric field, magnetic field. These three components are perpendicular to each other. So one of them may be electric field, that because it is a light equation, so definitely it's a wave equation. In that what that y indicates the displacement of electric field, means movement of electric field, because these three in the lighter there is a component of electric field because it's an electromagnetic radiation. So among these four options, the D1 is holds good for this explanation because it is a light is electromagnetic radiation. And about these three options are related to medium only, but only D option is related to the wave here, means light here. These three are related to medium, and the D option is related to only wave related. So Y is a electric field. So it is there in the light. Electric field is there in the light. So D option could be the answer. Now we'll move on to the next. Which of the following properties of light? Which of the following properties of light conclusively support wave theory of light? I'm repeating. Which of the following properties of light conclusively support wave theory of light? Yes, already in the morning we discussed to describe a light concept. There are so many theories, and of course we entered the concept in the morning with Huygens wave theory. We discussed two properties over there. Now among these four options, the following properties of light conclusively support wave theory of light. So among four options, which one is supporting the wave theory? So wave theory can explain some properties and failed in some cases. Similarly, the corpuscular theory means by assuming light as a particle nature, and that also explains successfully some phenomena and failed in some other phenomena. Means all the stories were, means the theories were couldn't explain most of the phenomena. See here is asking, stressing about the wave theory only. Which of the following properties of the light conclusively means conclusively support the wave theory? Finally, which of these four is supporting the wave theory they're asking. So first option is light obeys laws of reflection. Yeah, it's a wave theory. Wave theory. Light obeys laws of reflection. See, this A option is holds good for both the cases, both the particle nature and the wave nature, laws of reflection. Okay, so is exclusively it is not supporting wave theory. And the coming to the second option, speed of light in water is smaller than the speed in vacuum. I'm repeating, speed of light in water. Yeah, actually the speed of light in air is fixed one. When it is incidented in water, then that velocity, speed of that, speed of that light will be smaller than the speed of the vacuum. Yes, this is true because we are treating this as wave theory here in this case. So when traveling in a medium, we discuss denser medium and rarer medium. So there is a change in refractive index. Here comes the change in velocity or speed. So this may be a chance of correct answer. And moving to the next option, light shows interference. Light shows interference means it supports. What is interference? Actually, interference is a superimposition of two waves. Superimposition of two waves at a particular point at a particular time. Then the resultant will be vector sum of the individuals, that is about the this either displacement, the frequency, right? So the light shows the interference. So this is possible only wave case. See, I'll give one example. Superimposition is only possible for waves, not for the particles, because interference is nothing but what? At a particular point, at a particular time, if the two waves are superimposed, means incidented, is possible because wave has no mass. Wave has no mass. Only wave, only means it's a feeling that means we can have a sensation, but we cannot see the wave over here. Okay, the wave we cannot see that it is a present here or there. So wave is only the massless quantity, but physically we can't see. But when these two means any two waves or two or more waves are possible to intersect at a particular point at the same time, but if light is in the form of particle, then it is not possible because two particles at a particular time at a particular point cannot be occupied. So the wave theory supports this interference well. Okay, so interference purely works under this by assuming the light is in a wave form, then only it is possible. Otherwise, interference is not possible. And coming to light shows a photoelectric effect. Yes, we'll see this photoelectric effect. We know what is that when a particle or a photon is incidented on a metal surface, then electron will be ejected out. That was a statement for this photoelectric effect. Then actually the light is incidenting on the metal surface. But according to Maxwell, that light is consists of a photon, that is a packet of energy. So whenever there is an energy, then there is a particle, remember. Whenever there is a particle, there should be some mass and some energy will be there. So when the particle is collided with the metallic surface, again metallic surface is nothing but particles, again ions, particles will be there definitely. So this the photon is incidented or collided with the metallic particles and they release energy in the form of electron. So photoelectric effect, here it is, there is no concern. See, in the whole discussion, we didn't use the wave here. The light is a photon incidented on a metal surface, again particles, and ejected with what? Again particle, that is electron. So photoelectric effect is strictly no way concerned to the wave theory. So the best means I hope two options are there in this. That is speed of light in water is smaller than, okay, and the speed in vacuum, yes, and light shows interference, yes. These two are possible only when the light is treated as a wave. So these two options are obeying what supporting this wave theory, right? Then we'll move on to the next one. Now we'll see when the light is refracted into the medium, what happens, we'll see. Okay, when the light is refracted in the medium. So we know when the light is refracted, what happens, we'll see now. Its wavelength and frequency both will increase. I'm repeating, its wavelength and frequency both will increase. See, first of all, we should understand what is this refraction. See, in the medium, for example, refraction means what? Definitely, if there is a change in medium, then it will refract. Okay. Now, for example, if the light ray is moving in air and is refracted into the other medium. So let us take it is moving from air and is entered into the glass or water medium. Then refraction takes place. Then what are the changes going to occur? We'll see then. What are the options are given? It's wavelength and frequency both increase. Wavelength and frequency both will increase. V is equal to n lambda. We have a formula. V is equal to n lambda. V is equal to n lambda. V is equal to what? V is the velocity, n is the frequency, lambda is the wavelength. V is equal to n lambda. See, refraction takes place. Refraction means definitely what happens? Refraction takes place only when it's a denser medium takes place. So denser medium means obviously it's a more dense medium. In that medium, more denser particles will be there. So definitely the velocity of the light ray decreases. Yes or no? So velocity of light means light particles need to move in the medium by making number of collisions with that material particles, so that the velocity of that light may decrease. So once it is decreased, so I told you the relation V is equal to n lambda. If the velocity is decreased, both the frequency and the wavelength also decrease. But here in the first option is given increase, so it is not possible. Now moving to the second option, it's a wavelength increases and frequency remains constant. Look at this, it's a wavelength increases. It's a frequency remains constant. See, wavelength, for example, red color, okay, is entered into the other medium. It is not compulsory that while it is refracting, it should be in the same wavelength, means the same red color. Maybe some faintness will be there, some what's that, some of the wavelength may refract, some of the may reflect. So the same amount of wavelength cannot pass through that. So that's why it's asking that increase. It's wavelength increase is not possible. Increase is not possible. Okay, and frequency remains constant. This may be a chance. Frequency maybe remains constant while it is moving from one medium to another medium. Frequency, what is frequency? Number of vibrations per second. Number of oscillations made by the material particle, light particle per second may be same. Okay, because always the velocity of light is constant because because of the refractive index there may be a change, but wavelength cannot be increased. Wavelength cannot be increased. Okay, so B option may be wrong. And its wavelength decreases. Yes, it is possible. Wavelength decreases is possible, but frequency remains constant. Yeah, frequency also remains constant. Yes, this may be a possible. And its wavelength and frequency both decreases. Both decrease. Frequency cannot decrease. Frequency cannot decrease. Wavelength and frequency both cannot be decreased. Both cannot be decreased. So here the wavelength may decrease, means most desirable options are C1. Its wavelength may decrease, but frequency remains constant. This is possibility. And observe this. First one is not possible. There is a change in velocity. The last one is not. It's not compulsory that both should decrease, because the frequency should be constant, right? And most desirable. See, the decreasing of wavelength increases, and this is also not possible. B is not possible. So most desirable option is C, because wavelength there is a chance of decreasing and frequency remains constant. Yes, this is possible. So C option is correct. So here, when the light is refracted, when the light is refracted, which of the following does not change? Which of the following does not change? Yes, it is related to the previous question. Yeah, when the light ray is refracted, which of the following does not change? Wavelength may change. I told you when is changing into moving into the another medium, it may change. Yeah, frequency, it won't change. And velocity, I told you, as the density or refractive index of the medium changes, then velocity changes. Obviously, when wavelength and velocity changes, amplitude also changes. Remember that you strongly fix that. Then when the light ray is refracted, which one is constant? Frequency will never change. That will be constant. Now we'll move on to the next problem. Huygens principle of secondary wavelets may be used to. Yes. I'm repeating. Huygens principle of secondary wavelets may be used to. Secondary wavelets. Okay. We studied in the morning that Huygens principle, there are two principles are there. Okay, it's related to the secondary wavelets. Why they are using these two principles? Right? So they are using to find the velocity of light in vacuum. No, already we know the velocity of light in air. Finding the Huygens principles are not used to calculate the velocity, it's already known. Right? That is so it is not used for that. And next one is explain the particle behavior of the light. Particle behavior. So Huygens principle is not explained to behavior of the particles, means their energy, the force, and in which direction or what displacement. So those are not. See, Huygens principle is explained only when the energy is supplied to that, means some energy supplied to the medium, then material particles or medium particles start vibrating with a certain frequency, then they release energy. That disturbance, nothing but disturbance, is distributed to the neighboring particles. So with this, what we can calculate, explaining the behavior is not true. And finding the new position of the wavelet. Yes, this C option is correct. Exactly. Okay, C. What is C option? We can identify the position of the wavelet. I hope we discussed in the morning the derived for this. We derived for this. Yes or no? We identified the position. We identified the position of the particle we have drawn a tangent of the wavelets produced by the or the source. Okay, in the morning we discussed that. When A bar and B bar, two waves are incidented on the medium, then at a point A, the first particle is started vibrating and sending the secondary wavelets. So with that, we can identify the position of the wavelet. And in the morning, we derived the expression for it. And we proved that that refraction is nothing but what Snell's law explains the Snell's law. Yes, Snell's law. What is Snell's law? N1 sin I is equal to N2 sin R. So where N1, N2 are the refractive indices. We proved in the morning, if I'm correct, that. So this Huygens principle used to describe the two things here. The options are C and D is accurately correct. And the first one is no way concerned to this because it's the velocity of light. Using this principle, we cannot do that. And explaining the particle behavior. Particle behavior is no, means a type of the particle, whatever the particle it is. Behavior is not concerned. But what is the advantage of principle of secondary wavelet is, what is the principle of the secondary wave? Used for what? Obtaining the Snell's law, means it is used to support that Snell's law and all. What is Snell's law? That is a law of reflection or laws of refraction that we studied in the morning. So it's nothing but Snell's law. Okay, and the positional wavelet, yeah, that is also we have done in the morning. So C and D options are correct. And moving to the next problem, which of the following sources gives the best monochromatic light? What is monochromatic light here? Monochromatic, mono means single, chromatic, chromatism means color. Monochromatism, single color. What they're asking, which of the following sources gives the best monochromatic light? Monochromatic light, single colored light. Which source will give single colored light? Single colored means a particular color, right? Yeah, here are the options. A is a candle, so which gives candle gives which color? Candle gives all the colors. Candle gives all the colors, right? There is no specific color over there. All the 7 colors it can give. Why only 7 colors? 7 colors means our eye is sensible only for 7 colors with GR, and beyond that, the eye is not sensible. Eye cannot detect. So that's why we can identify only the 7 colors. So monochromatic means what? Either of means among those 7 colors, which source is giving particular color they're asking. Yes or no? The problem what they're asking, which source specifically gives a single wavelength. So candle, definitely it won't give a fixed color. It is a combination of all the colors that with which our eye is sensible for what colors. In the bulb, definitely it is not a monochromatic. If you see the construction and working of this bulb, it is not a single color. It's not a single color. It's the excitation and de-excitation process of the particles takes place inside the bulb, inside the filament, inside the tungsten material. If you see that all the material particles are exciting and de-exciting, there the number of particles de-excitation is not continuous. So that's why it is not a monochromatic. It's not a single color, right? And coming to the mercury tube. Mercury, tell me where mercury gives which color? Mercury bulb is a pure white color. It's a pure white color. Mercury bulb, we know well, it's a pure white color. And also we know that white color is a combination of 7 colors. So don't think that the mercury bulb, of course, it gives white color. It's a single color only. But the white color is the combination of 7 colors. So monochromatic, see, not given by the mercury. Now coming to the laser. Yes, laser is available all major colors, right? Single color. It can give the single color. Laser itself is an acronym. Laser itself is an abbreviation. Light amplification by stimulated emission of radiation. So in that process, amplification, okay, light is amplified by stimulated emission of radiation process. So in that radiation process, all the de-exciting particles will be, with respect to time, they will de-excite. So the equally spaced pulsed radiation will come out. So that is a monochromatic source. So laser is a monochromatic source. It can exhibit red color, green color, blue color. So particular fixed wavelengths can produce by laser. So the only laser source can give monochromatic source. Yeah, now moving to another question. The two sources are called coherent if they produce waves. I hope we discussed this concept in the morning, that two sources are called coherent when they can say coherent sources. If they produce of equal wavelengths, of equal velocities, having same shape of wavefront, and having a constant phase difference. Yes, in the morning we discussed that with the diagram. Okay, with the diagram, that coherent. Coherent means what? When both the laser, we took then as an example in the morning, that for that all the rays are coming out from the source with the same phase. Okay, for example, the problem what they are giving, two sources are there. Okay, two different sources, mean two sources. Actually, it's the best explaining this in interference concept, that to Young's double slit experiment. So two sources are there which are coming out from the two sources, two rays produce waves. Okay. Now, what is the condition to be coherent? They're asking what is the condition to be that both the sources gives the coherent waves. If they are of equal wavelengths, yes, wavelengths may be same, but one wave may start earlier, another wave may come late, that we discussed in the morning, right? So wavelengths, if they are same, then they cannot be coherent. Wavelengths, if they are same, they cannot be coherent. Next, of equal velocities. No, this is also absolutely no way concerned. Velocities, if their velocities are same, see, if the velocities are same, that for example, I am shouting and you are also shouting with the same frequencies and all, then what? Can we say that both the rays are moving with the same phase, the same velocity, maybe the same, but we cannot say that the coherent source. Coherent is possible only, the coherent is possible only when all the waves which are coming from the source are moving in the same phase. Same phase. Now see the C option, third option, having same shape of wavefront. Shape of wavefront. Shape. No. Wavefront is what? Wavefront is group of all the wavelets. Okay, so all the wavelets that we have seen in the morning for the derivation, that some wavefronts are reached one point and earlier, and another wavelet is still at another point. So they are out of phase. So they cannot be, means see, of that path difference, if we are emitted or deleted, then we can say wherever both the rays are parallel, then we can say that both are incoherent. Okay, so the moving to the fourth option, that having a constant phase difference. Yes, constant phase difference may be the answer. That why we'll see. Phase difference, I'm telling you that in three cases, maybe the light rays are coming out with the different wavelengths, with the are shape shape of the wavefront may be different, may be equal, but wherever the first wave is coming out, exactly one wavelength, exactly after one wavelength, the second wave is started, and both are moving. There may be a path difference, but both are moving in the same phase. And one more thing, one wave is moving with 90 degrees upward, means totally both the rays are coming out from the two sources with 180 degrees difference. For entire journey, if both the waves are maintaining the same 180 degrees difference, then that is called constant phase difference. So if they are moving with the same direction, with the same velocity, with the same velocities, wavelengths, but the condition is the difference between the two waves in terms of phase should be constant. They should not deviate for entire journey. So D option may be correct, that having a constant phase difference means among four, the D option is strongly giving information that whatever the possibilities of wavelength, velocities, shape, but minimum requirement for the coherent source is what? Phase difference should be constant. Okay, and now we'll move on to the next question. Yes. When a drop of oil is spread on water surface, imagine this. When a drop of oil is spread on water surface, it displays beautiful colors in daylight, because so here there are so many theories, all these are the properties of light. All four options are properties of light. Only the light can display these properties. All these are properties of light: dispersion, reflection, polarization, and interference. All right. So among these, among four, which one is giving the colors on the oil which is spread on the water? You might have experienced this. Usually you can see that during rainy season, okay, on the roads, the vehicles are moving, and on the roads full of rainwater. On that, some vehicle means some that fuel, what's that, either petrol, liquid, diesel, the drops on the surface of the water on the midday. If you see that on the layer of that water, okay, on the surface of that water, you can see some beautiful rainbow colors on that surface, on the that fuel. You might have experienced that. So that's what why they're asking. Okay, the question is that only. So why it is displaying beautiful colors, and what could be the reason? Yes. So here is the dispersion of light. So we should understand what all these are. Then only you can come to the conclusion that dispersion. What is dispersion? Yes, the most desirable option is dispersion, that we know. Yes, when the light ray passing from one medium to another medium, especially prism. Dispersion is prism. Okay, when the light ray is incidented on the prism, then what happens? It gives the 7 colors. Yes, right. But the condition is the in the prism. If you see the construction of the prism, both the reflecting surfaces are inclined with a certain angle. If you see the image, see construction of the shape of the prism, both the reflecting surfaces are inclined at an angle. Both are not parallel. Okay, both are not parallel, inclined with certain angle. Some angle of prism is there. So that is the solution for, that is the reason for dispersion of 7 colors. We're getting 7 colors. That is only the reason. If the same prism, if it is in a square shape, it cannot give the 7 colors. So here, oil drop is on the surface is like a slab or a film, a thin film concept. It's like in a slab, a layer. So layer means it cannot give 7 colors, right? So A option is omitted because dispersion is related to what? A prism. That is only the two reflecting surface should be make some angle. So here is the clear the concept. Now reflection of light. What is reflection? Whenever the light ray is incident on the surface, then it will come back. Yeah. So we have seen so many examples. Whenever the light ray is incidented, it will come back with the same intensity, same velocity, same wavelength. But how it can give the reflection cannot give the 7 colors. Reflection cannot give the 7 colors. Right. And the polarization of the light. Polarization of the light. See, polarization is the phenomena that it can give only one ray. Means, for example, we're going to discuss this concept in the coming classes, that when an electromagnetic radiation, electromagnetic light is incidented on such a material, this Nicol prism, we call that material. Okay, so Polaroids we call it. So when the light ray is incidented on such materials, what is the nature of that is, that material is, it separates both electric wave and magnetic wave, like means E ray and O ray like. So what is the nature of this polarizer? Polarization is nothing but one-sidedness. It gives only the separation, one-sided. It can give only one light. So it cannot give the 7 colors. What's the question here? Displays beautiful colors over there. Why? So now coming to the interference of light. Yes, so interference is what? When the two or more lights, especially white light, is incidented on white light. For example, I told you know the example that when the on the roads of on the roads during rainy season, that the vehicles are moving, then we can see on that, see the drop of the oil fuel drops on there. Then what happens? You can see when the sunlight is incidented on that. So remember, the sunlight is nothing but a combination of all wavelengths, all colors. Okay, when that colored beam is incidented on the drop of oil, I told you that oil is a thin film, a thin layer will be formed over there, and due to that double refraction. Okay, so some of the light may be penetrated through and some of the light will be come out, and due to the white color of the incident light ray, and reflection takes place in the 7 beautiful colors. So only the reason for this beautiful colors is interference of light. So now we'll conclude with this session with one more discussion. Yeah, we'll discuss this one. This is actually what says here. This is the source. Okay, one single slit is arranged, means some gap will be there, and through that gap the light ray is coming out, and this light ray again is restricted with the double slit, means 2 slits are there, and from these two slits the light ray is coming out with the 2 waves like that. And these 2 waves are coherent because the wavelength is same, intensity is same, frequency is same. So that's why both are, we can say, both are having the same wavelengths. So 2 waves are superimposed. This is called interference concept. Superimposed. Okay. Then alternate bright and dark, that is maxima and minima pattern that we can observe. So this is the pattern, that is interference pattern on the screen that we can see. Alternate bright and dark fringes. Dark is a minimum, bright is a maximum. So this is called interference pattern is possible only when the 2 rays or 2 or more rays are superimposed at a particular point at a particular time. Then we'll definitely discuss this more elaboratively with deriving some intensity of these light rays and all. Okay, so here observe this. Crust and crust will be there, trough and trough will be there. Okay, for each and every source, it exhibits wavelets. For all the wavelets, there will be what? The crust and troughs will be there. So whenever the one crust of one wave and another crust of another wave, both are superimposed, then we'll get the maximum. We'll get the maximum. Okay, so we'll continue this in the next class, and we'll stop here with this, and Keep practicing, and better I'll give one suggestion on this chapter. Better you prepare from synopsis, then it will be easy to solve the problems in the next class. Thank you very much.